Alright, so let's put whatever we learn into practice and let's take a look at this question. So this question wants us to arrange the three salts in order of decreasing pH when equal concentration of them are dissolved in water to form an aqueous solution. So this question immediately tells you that this is a salt hydrolysis related question because the main characters here are all salt. And let's see, so we are supposed to determine whether the salt is capable of forming a neutral, acidic, or alkaline solution when dissolved in water. So let's take a look at the salts one by one. Let's start off with our sodium nitrate. So I would like to focus on the anion first. So the anion, NO3 minus, is a conjugate base of our nitric acid, which is a strong acid, right? So once again, the relationship between strong acid and a weak conjugate base, or a weak acid strong conjugate base, means that our nitrate anion would be a weak conjugate base. You guys probably are tired of me like repeating this over and over again, but it's very useful, this mantra, to help to solve these kind of questions. So since it's a weak conjugate base, what does it mean when it dissolves in water? This means that your nitrate is unable to hydrolyze or react with water to produce your OH minus ions and your HNO3. This thing cannot happen because since it's a weak base, it will not be able, it's not strong enough to take a proton from water. Therefore, your nitrate will form a pH. If you're focusing on the anion only, your pH of the solution will still be 7. So now let's take a look at your cation. The cation is your sodium. It's your Na+. So this one, we'll be thinking in terms of condition 3, whether it's a metal cation with high charge density. But since it only has a charge of +1, I wouldn't say that it will have a high charge density when, it's not a cation with high charge density. So it's unable, when it dissolves in water, it will not be able to form a complex ion, and it will not be able to polarize the OH bonds enough to for the H2O molecules to get deprotonated. Okay, whatever I say now means you probably need a diagram to try to understand it, but just to know, since it's not a high charge density cation, it will also result in there won't be any H plus or OH minus ions formed. Therefore, this salt would overall be pH 7. Okay, now let's take a look at the next salt. The next salt we have is our KCN. So let's take a look at the cation first now. So cation is your K plus. K plus similarly has a low charge density, low charge, therefore its charge density will be also relatively low, and it will just be the same thing as Na plus. When dissolved in water, they won't be able to hydrolyze water, and there will be no excess H plus or OH minus ions formed. So for now, the pH is still 7 for the cation side. Let's take a look at the anion side. So the anion here is your Cn minus. Your Cn minus is a conjugate base derived from the acid HCN. And since HCN doesn't belong to our big three of the strong acids, it will be a weak acid, which makes your Cn minus a strong conjugate base. Okay, so since it's a strong conjugate base, what can it do in water? Your Cn minus can react with H2O, is strong enough a base to deprotonate H2O to give you HCN and a bit of OH minus ions. And again, OH minus, since there's a production of OH minus ions, this makes the solution pH more than 7. That's why it will be alkaline. And lastly, let's take a look at our final salt, what's it called, chromium nitrate. Oh my god, yeah, okay, chromium nitrate. So if we look at the anion first, anion is a nitrate anion derived from HNO3. So it's the same story as your NaNO3's anion. It will not be able to hydrolyze or react with water. So the pH for the anion side will still be 7. But now if you focus on the chromium cation, it has a charge of +3. So it is around the same same charge density, or it will as Al3 plus, or it will be considered as a cation with high charge density. So as a cation with high charge density, it can too perform the same reaction when dissolved in water, form a complex ion, and the complex ion can react with a water molecule to, okay, there's not enough space, but eventually you can form H3O plus. So overall, this makes this salt having a pH of less than 7 is acidic when dissolved in water. Therefore, what is the answer to this? So since they want us to list it in decreasing pH, our salt with highest pH would be your KCN first, followed by your NaNO3, which is pH 7, and your chromium nitrate, which will be pH lesser than 7. And that's how you solve this question.